Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Dear students, welcome back. Alhamdulillah, till now we have studied series circuit, parallel circuit individually. In this chapter, both series and parallel resistors are combined into series parallel circuits. In many practical situations, you will have both series and parallel combinations within the same circuit, and analysis methods you learned for series circuit and for parallel circuit will apply. Important types of series parallel circuits are introduced in this chapter. These circuits include the voltage divider with a resistive load, the ladder network, and Wheatstone bridge. The analysis of series parallel circuit requires the use of Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law. And the method for finding total resistance and power that you learned in last two chapters. The topic of loaded voltage divider is important because this type of circuit is found in many practical situations. One example is the voltage divider bias circuit for our transistor amplifier, which you will study in a later course. Ladder network are important in several areas, including a major type of digital to analog conversion, which you will study in digital fundamental course. The Wheatstone bridge is used in many types of systems for the measurement of unknown parameters, including most electronic scales. So, the outline is identifying series parallel relationship, analysis of series parallel resistive circuit, voltage divider with resistive loads, loading effects of a voltmeter, ladder network, the Wheatstone bridge, and chapter objectives are identify series parallel relationships, analyze series parallel circuits, analyze loaded voltage dividers, determine the loading effect of a voltmeter on a circuit, analyze ladder networks, analyze and apply a Wheatstone bridge. Let's start. Now I am going to share you with the chapter slide. So you can see my screen now. Now you will see. Okay. Yes. Now you are able to see my chapter slide. Yes. The first topic is identifying series parallel relationships. A series parallel circuit consists of combination of both series and parallel current paths. It is important to be able to identify how the components in a series cir- or component in a circuit are arranged in terms of their series and parallel relationships. After completing this section, you should be able to identify series parallel relationships, recognize how each resistor in a given circuit is related to other resistors, determine series and parallel relationships on a PC board. Now, you have to look on the paper. Let me share with your the camera screen. Now you can see the screen. Look at this circuit. Yes. R1, R2, R3, point A, point C. So, if you see this circuit, it's a simple series parallel combination of the resistors. Notice that resistors from point A to point B is R1. The resistance from point B to point C is R2 and R3, and both are in parallel. The total resistance from point A to point C is R1 in series with parallel combination of R2 and R3 as indicated. If you look, if I solve parallel combination of R2 and R3, there will be no effect on the circuit connection of R1. So this can be redrawn as R1 and R2 parallel with R3. The result will be shown here. So I can say that R1 is in series with parallel combination of R2 and R3. When the circuit of figure, this figure is connected to a voltage source like this one, the total current is through R1 and divides at point B into the two parallel paths. One path is R2 and the other path is R3. And these two branch currents then combine here, and the total current into the negative side of the battery of volt or voltage source negative terminal is will be sum of current through R2 and R3. Now, to illustrate series parallel relationship, let's increase the complexity of the circuit. This circuit. I will increase complexity step by step. Now, I'm going to draw another circuit. Look at this circuit. R4, R1, R2, R3. The only difference between previous circuit and this circuit is R4. Now, the resistance between point A and B is sum of R1 and R4 as both are in series, and this combination is in series with the parallel combination of R2 and R3 as I mentioned earlier. Have you got it? The Again, the combination of R1 and R4 is in series with the combination of R2 and R3. So, what can I say? This will be R1 plus R4 will be added with the parallel combination of R2 and R3. Now, I am increasing complexity a little bit more, and I'm just adding one more resistance here. This is R2 and R5. Now, R5 is connected in series with R2. The series combination of R2 and R5 is in parallel with R3. I repeat, the series combination of R2 and R5 is in parallel with R3. This entire series parallel combination is in series with series combination of R1 and R4. If we solve it, the whole solution will be R2 plus R5. It is parallel to R3, and it is in series with series combination of R1 and R4. This is R1 and this is R4. So you see, things are getting complex, but the base is as easy as it was in series and parallel combination. Nothing new. Now I am increasing its difficulty a little bit more. If I draw a new copy of the circuit, R1, R4, here R4, R1 as in previous circuit, R2, R5 of the previous circuit, and R3 is in parallel with R2 and R5. This is same between point A and point C. So what is here? Now R6 is connected in parallel with the series combination of R1 and R4, and the series parallel combination of R1 R4 is in series with series parallel combination of R2 R3 and R5. So what I can do, I can do make small portions of the circuit. R2 R5 is parallel with, or it is better to write here, R2 plus R5 is in parallel with R3 plus R1 R4, series combination of R1 and R4 is parallel with R6. So hopefully you got the idea of the main concept. Now we will uh, have a small example here. R2, R3 and R4. Now please tell me that how can write the formula to solve this circuit. Just if you are getting confused, just make direction of current that is flowing here. So current is coming as a combined flow and splitting in R2 and R3 and again combining at R4. So what can I say? It is a series combination of R1 with parallel combination of R2 and 3 and R4. I repeat, it's a series combination of R1 R uh, with R4 and parallel combination of R2 and R3. Now, there is another example. What if circuit is drawn like this? Plus minus Vs. So here we can see that end-to-end connection of R4 and R5. So I identify that R4 is in parallel with R5. R2 and R3 are also in parallel, and current it flows starting from here, divides here and combines again. After combination it's separated again. So we can say that R1 is in series with parallel combination of R2 and R3, that is in series with parallel combination of R4 and R5. R1 plus parallel combination of R2 and R3 plus parallel combination of R4 and R5. Now what about the circuit that I'm going to draw here? R1, R2, R3, R4, R5. So what can we say that current is flowing this way, combine here and again splitting here. So R1 is in series with R2, parallel combination of R2 and R3 and in series with parallel combination of R4 and 5. So now I'm going to describe a parallel combination in one more circuit, series parallel combination. If you notice, we are increasing the complexity of our questions with every new problem. So R1, R2, R3, R4, R5, R6. Now we have to describe the combination between A and D. If you see the whole circuit, it is a great cause of confusion. But if you look at smaller portion of the circuit, you will never get confused. Solve in chunks. At which chunk of the circuit that I will solve, and it will not create any disturbance to the connection of other resistances. The first one is R2 and R3. So replace this R2 and R3 by one resistance. This is R2 plus R3. Now, which connection can be solved? If I see this series circuit is in parallel with R4. So what I can do, I can replace this connection as R2 plus R3 is parallel with R4. So I can replace the whole bunch of the resistances by a single resistance. This is R2 plus R3 in parallel with R4. Now you see the complexity is being reduced here. This series parallel combination is in series with R5. What will happen? The whole stuff will be added with R5, and it will be shown by the one resistance. Their combination will be one resistance. This is resultant of whole the resistances that I have been solved. Now what will happen? Now this whole stuff is in parallel with R6. What I will do here, R6 is in parallel with R5. I place R5 to left plus R4 parallel with, or I can simply write in the same way you are watching here to avoid confusion. Now, the whole combination is in parallel with R6. And now, what will happen? Now, this is no more R6. This is combination of these all resistances. And in the end, what I will do, I will simply add one more bracket, and R1 is in series with this whole stuff. So hopefully you got the idea. R1 is in series with parallel combination of R6 with series combination of R4, R5 and parallel combination of R4 and series combination of R2 and R3. So step by step you can solve a question. It will create easiness for you, otherwise you will get confused by watching the circuit. So now some tricky questions. You have to describe total resistance between each pair of terminal. Means we have to find resistance from A to B, from B to C, and from A to C. If I look at here, let us say I am looking A to B, that means source is connected somewhat here, and this is not being used. If source is connected here, then what I can say that R1 is in parallel with series combination of R2 and R3, as when current start flowing here, current is dividing into two paths. That one path is for R1, the other path is from R2 to R3. So I will say that R1 is in parallel with series combination of R2 and R3. Hope you understand that. Now, what I am doing, I am connecting our voltage source between point B and point C. So, between point B and C, what will happen? Current will start flowing here and here. One path is from B to C is from R2, the other path is from R3, so that I can say R2 parallel with series combination of R1, R3. And similarly, for point between point A to C, this is point B, this is point C, R3. So between point A to C, I have connected voltage source here. What will happen? Current will enter the circuit in two paths. One path is from R3 and the other path is from series combination of R1 and R2. What will be the result? R3 is in parallel with R1 plus R2. So, hope you understand the situation. Now, it's time to determine the relationship of the resistors on a printed circuit board. The same practice that we did in uh, previous chapters. What I will do, I will uh, open paint application, and inshallah we'll continue. So it is taking time to open, but just now look at the screen you are watching here is now we have to determine the relationship between the resistances that are being shown in this printed circuit board. So these two terminals are showing that this is our entering point of the circuit, or this is our uh, point where source is connected to the circuit. So I will just draw current path. So if you look here, I can use, should I use pencil? Okay, current is black will be much better. Current is here, going this way, and this point current is splitting in two paths. First point where current is being splitted, and the same current is flowing into these two, R4 and R1. So again, current is flowing further. One more node where current is spreading and flowing to through R2 and going back to the home. Afterwards, current is flowing through this resistance and through this resistance current is. But if you see, the same current is again distributed in R5 and R6. If you look at here, the current that is flowing through R3 is again dividing in R5 and R6 and then again combining at this point. So the whole combined current is then flowing to R7. Then what can I say? I am writing on the paper that series combination of R1 and R4 is in parallel with R2 and that is in parallel with R3. Okay, that is in we can say that the current is flowing here and parallel combination of R5 and R6 is in series with R3, that is parallel with the whole stuff. So R3 is in series with parallel combination of R5 and R6 and the whole circuit is in series with R7. Now look at the paper. The whole circuit that I drawn, you can take screenshot to analysis that R1 series combination of R1 and R4 is in parallel with R2 and that is parallel with series combination of R3 with parallel combination of R5 and R6 and the whole stuff is in series with R7. It's a bit complexing to understand and to grasp the idea, but we have to uh, digest somehow. Okay, in the end of this lecture, I will share a simple quiz with you to revise basic ideas of series, parallel, resistive circuit, and I will share simple numerical problems to uh, understand, to check your understanding. Then you will be asked about the parallel arrangements and series arrangement of the uh, different circuit that I will show. I will share with you after this lecture. Till now, what we have concluded, we have till now understood how to identify a series parallel relationship in a given circuit. I started with a simple series parallel, most simple circuit with two resistors in parallel and one in series. Then I continued with two resistors in series, two in parallel. Then I was increasing the complexity by two resistors in series with parallel with two resistors in series, parallel with one resistance. Then I added one more resistance that was in parallel with the series combination of first two, and same as in the one more resistance in parallel with the series of second combination. Then I followed some examples. With this, I conclude this part of this lecture. Mm. Inshallah, in next part, we will continue our understanding with the analysis of series, parallel, resistive circuit. And in analysis part, we will focusing on the to solve the numerical problem. Till now, we have just identified. We haven't solved any numerical problem till now. We will solve in next analysis part and check what is the total resistance, what is total current, and what are branch currents. Inshallah, we'll meet you in next uh, recorded lecture, and afterwards we will have a interactive session. Till then, take care of yourself. Allah Hafiz.